quadratics in factored and standard form with Miss Thungaraj. Hi grade 10s, it's been a long time since we've seen each other, and we're going to start today on an assignment about quadratics, and I'm going to work with you throughout the assignment, and I'm going to do a video each day for the next 2 weeks, and that will help you to complete it. So I'm really happy to see you again. I hope you've had a good week off catching up or just relaxing and resting, but I'm happy to get back to math with you today. Today we're going to look at quadratics in factored and standard form. We've already actually looked at quadratics before. We've talked about drawing a quadratic, finding the zeros, finding the vertex, finding the axis of symmetry. We've talked about quadratics in factored form. We've talked about how by looking at the numbers inside the brackets we can find the zeros. So today our job is just to match the equations that are in factored form with the equation that is in standard form. Because when you are working with quadratics, there's two ways you can write the equation: standard form or factored form. And it doesn't matter which way you write it, you can still get the exact same graph. So let's first remind ourselves about factored form. This here is an equation in factored form. And because in the bracket it says x plus 1 and x plus 2, remember from several weeks ago, we know that if it says plus 1, the 0 or x-intercept is minus 1. And if it says plus 2, the 0 or x-intercept is minus 2. So we can easily do that on a graph. So let's look at the graph right now. This is my graph, and you can see that it says plus 2 in the equation, but it goes through minus 2 on the graph. It says plus 1 in the equation, but it goes through minus 1 on the x-axis on the graph. We've done this before. We have also found the vertex. We know that we have to do the bunny hops to find the middle to get the vertex. And so I've drawn a graph with bunny hops, and I can see that if I hop to the middle between -1 and -2 is going to be -1.5. So my vertex is going to be -1.5, comma, a negative number. And we've done that before too, but right now I just care about locating where on the x-axis the vertex is. So this equation is in standard form. Y is equal to x squared plus 3x plus 2. And what's awesome is that this equation actually gives the exact same graph as the equation in factored form did. So let's look at Desmos. And what I've done in Desmos is I've entered both of the equations, factored form and standard form, and I look at the graph, and the graph is the same. So that must mean that there is something interesting about factored form. Well, factored form tells us that if it says plus 2 and plus 1, it's actually minus 2 and minus 1 along the x-axis, the zeros or x-intercepts. And so the standard form must tell us something interesting as well. And if you notice, at the end of the equation in standard form, there is a plus 2. And if you look at the y-intercept, the y-intercept is also plus 2, which is interesting. So perhaps the equation in factored form tells us where it crosses the x-axis. It said plus 2, so it went through minus 2 on the x-axis. It said plus 1, so it went through minus 1 on the x-axis. And then perhaps that number at the end of the equation in standard form tells us where the y-intercept is, where it goes through the y-axis. Here is page 1 of assignment number 4, and I'm going to do one with you, and I'm going to leave the others for you to do today on your own. So what you're going to do is you're going to look at an equation in factored form, and first we're going to practice graphing in factored form. We're going to practice finding what the x-intercepts are by looking at the equation. We're going to graph it. And then we're going to find which of the equations in standard form goes with it. What's the matching equation in standard form? So you're going to play a matching game today. And when you're done that, you're done for today. So you want to match the factored form to the standard form. We've already done the first one. If you look at the first equation on assignment number 4, it says y is equal to x plus 1, x plus 2, and we know that that's the equation x squared plus 3x plus 2. And don't forget, what we've learned is that over here, this says plus 1, so it goes through minus 1. This says plus 2, so it goes through minus 2. And this number at the end of the standard form, the plus 2, that's where it goes on the y-axis, so it actually is a graph. Oops, that looks like that. Now, I'm obviously not doing a great job. I'm trying to film and draw at the same time, but that's what we've learned about factored form and standard form. And also the interesting thing is, if you take this +1 and +2 and you multiply them, 1 times 2 also gives you the 2 that's over there. I wonder if that's be a pattern we're gonna see over and over again. So let's look at this second equation in factored form. It tells us -1. If it's -1, that means it's gonna be +1. It tells us +3, so it's gonna be -3, -1, -2, -3. This is gonna be one x-intercept, or 0, and this is another x-intercept. Don't forget there's 0 right here. We want a bunny hop. 1, 2, 3, 4. The middle is at -1. And it's going to go like, oops, like that. Okay, now let's see if we can use the same trick. Here it was +1 and +2, so it was -1 and -2, and +1 times +2 gives you +2, and that's where it touches over here. So let's look here. Here's a -1, here's a +1, here's a +3, here is a -3. Now, if I take these numbers, the -1 and the 3, -1 times 3 gives you -3. I wonder if that means that this right here will be -3. Let's try with Desmos and see if that's right. So Desmos shows that we were right. The equation is x -1, so it touches +1 on the x-axis, and then x +3, so it touches -3 on the x-axis. And when we multiply -1 times +3, we get -3, and that's exactly where it touches on the y-axis. So now we want to find which one of the equations in standard form matches with this equation. Let's go back to our first example. We had the +1 and +2, and we multiplied 1 times 2, we got 2. And we knew that it was the same as this equation right here in standard form, where the last number was a +2. So what that suggests is we want to look for an equation in standard form where the last number is -3. So I'm going to go back to my list, my table of factored and standard form, and try to find an equation where the last number is -3. So when we look at the table, we see that actually the first equation in standard form, y is equal to x squared plus 2x minus 3, has that -3 or -3 at the end. So we're going to check to see if that equation gives us the same graph as y is equal to x minus 1, x plus 3. We'll do that now on Desmos. And I've gone to Desmos. I've entered both of the equations, the equation in factored form and the equation in standard form that I thought matched it. And I know you can't see the graph, but when I graphed them using Desmos, they were the exact same graph. So I know that I matched them correctly. So that's what you want to do for the rest of the tables. You want to graph both of them and check that they match together. So we've done 2 of them matching together. We've realized that x plus 1, x plus 2 matches up with x squared plus 3x plus 2 in standard form. And we've learned that x minus 1, x plus 3 in factored form matches up with x squared plus 2x minus 3 in standard form. So continue doing the matching, use Desmos to your advantage, check your work, and practice graphing the equations in factored form without Desmos to begin, to make sure you are practicing graphing on your own, not relying on technology. And don't forget that you can find me on Google Meet in the afternoons from about 1:30 to 3. You can find the link to the Google Meet on my Instagram page, and I'm happy to meet with you one-on-one to answer any of the questions you might have from today's video. Thank you so much for watching this YouTube video. Please leave me a comment so I know that you've watched it, and I know that you are learning along with me. Have a great day.